Module 2. This is me, Mrs. Jaffe. Today we're going to talk about terrestrial biomes, so I hope you're excited. Again, hopefully you've done the first two, and if so, you know the routine. You can obviously switch it up with colors of sticky notes. Just remember, it will be easier if you use the sticky note brand, as the adhesive is not as sticky as other brands that are out there. So here we go. So you probably remember from biology, if you took environmental science with me last year, then you also remember that we did talk a little bit about biomes. So this particular module focuses on terrestrial biomes, which means that we're talking about land, right? So um, we're going to go into details with aquatic biomes in a different module. So to start things off, what is a nice definition? Well, a biome contains characteristic communities of plants and animals that result from and are adapted to its climate. And so a big portion of this particular part of this first unit here, unit 1, is understanding how to read these climate graphs. And so when we talk about biomes, we're really focused on, as you can see here, the climate. And so that climate takes into consideration both precipitation and temperature, which is the driving force of what things can grow and what things can't grow in certain regions of the world. So if we look at this beautiful picture, you can see that in the figure that both types of cacti, they kind of look similar and they kind of grow similar. However, one is in one part of the world and the other one is in the other. So, when we look at latitudes, we can see that there are some similarities in different biomes. And so similar biomes will have similar key features, which makes for similar organisms. However, they're not the exact same, as you can see here. And so the biggest other thing to note here is that you understand the difference between a habitat and biome. So habitat is going to be a layer that's more specific to the biome. So think about a biome as like a large area, whereas a habitat is the specific area that the organism actually resides in. And so this picture also here, if you look at it, it does a great job kind of separating all the biomes by their precipitation and annual temperature. And so if we look now on the right side here, page 31, there's a great classification based on, latitude here, and you can see different biomes. So, if it's the same biome, they're going to have similar organisms. They may not necessarily be the exact same organism, but they're adapted to similar conditions. And so it's really important that you understand how to read these climate graphs. And if you look, these climate graphs are interesting in that they actually show both average precipitation and average temperature. However, you can see that there's two different the two different colored lines. Some types of diagrams will use like a bar graph and a line graph, so you just need to make sure that you read the actual key so you know what you're looking at. So here, precipitation is going to be represented by the blue lines, while temperature is going to be represented by red. And so you can see here on the bottom, these represent the month. So if you compare these two areas, A and B, you can actually see, you know, there might be some differences in precipitation. They might have like similar temperatures, but you can see that obviously the actual precipitation is different in these two biomes, which would totally make them completely different places throughout the world. So global distribution of non-mineral terrestrial natural resources. So examples of these would be water. So think about non-mineral natural resources as being things that are not being mined for per se. So they're not like gems, they're not coal, anything like that. But it's going to be things that we do use on an everyday basis. So obviously water we need, and it needs to come from somewhere, right? So water, trees for lumber, and obviously we know lumber is used for a lot of things. And then all of these are varied because of some combination of climate, geography, latitude, altitude, nutrient availability, and then also the soil. And so if we look at the list below, there are a few major terrestrial biomes that you need to be familiar with. Now, if you also took a look at the outline for the course, if you took a look at that online, this particular standard for the AP exam is pink, meaning that pretty much it's just going to be some type of very easy, I don't want to say very easy, but um, it's not going to be like required of you to do like a whole bunch of things, but you do need to be familiar with these biomes. I wouldn't be spending all my days though memorizing day in and day out of this particular chapter, but just have a familiarity with it. So we have the taiga, temperate rainforest, we've got the shrubland, we've got temperate grassland, savanna, desert, and then tundra. And so I'm just going to give you kind of like the quick overview of each, just so you kind of are familiar with it in case you've forgotten. So again, you're going to be looking at the climate graphs. Here, again, we're using blue is representing precipitation, red is representing temperature. And so tundra, a lot of people get tundra and taiga mixed up, but just think the tundra, it's pretty much the coldest of all the biomes. It's treeless because literally the soil just doesn't allow for any growth because it's just that cold. And if you look, it rains almost nothing there, which makes sense. It's like a little bit higher than 0 millimeters of precipitation a year, but not much more than that. And so because of this, you don't have a lot of vegetation. So tundra, think cold and treeless, very little rain. Then we move to the taiga, which is a little bit different. And if you look latitude-wise, it's actually a little bit lower. So it makes sense. It's not going to be as cold. It's still going to be cold, but it's not as cold as the tundra, meaning that it allows for tree growth. And the specific type of trees that can withstand this type of cold would be coniferous trees. So think about like pine trees. So think of the taiga as cold with very little precipitation. Like there might be a smidget more at certain times of the year. So you can see that, these highlighted months is when we do see the most amount of growing, but it still is short compared to other areas of the world. Then we move to all the temperate regions. We're going to talk about like temperate rainforest, seasonal forest, all that jazz. So if you look here, the temperate rainforest is it's very particular to like a specific area. So you want to think that there is an average temperature. So anywhere from, I put the Celsius, but also know that in Fahrenheit, 41 to 68 degrees Fahrenheit. So it doesn't get too cold and it doesn't get too hot. It's like that nice mediate, but it does rain a lot. So think moderate temperature, high precipitation. And the best place to think of is like out west. And specifically, if you've ever been to BC, Canada, British Columbia, that's like the best example. Vancouver, Washington, that whole area. And then we move to temperate seasonal forest, which is where we live here in New Jersey. So think that we've got warm summers, cold winters. But if we think about cold compared to, the tundra and taiga, it doesn't get as cold. But we do have more average precipitation compared to those, if that makes sense. And so you can see that we actually have like growing that occurs throughout, we have growing that occurs all throughout the months here. Then we move to the woodland or shrubland. The specific, you probably learned about it, is the chaparral. That's the specific name in California, but the actual biome name for any place that has these characteristics would be considered to be woodland/shrubland. So there's 12 months of growing. However, because of the high temperatures and very little precipitation, although there's a lot of growing, it can't grow too high. So if you think about the coast of California, it's greatest example. There are shrubs and that kind of thing, but not too crazy of growth happening right on the coastline there. Then we move to the temperate grassland, and you want to think, this is another example. This would be an example of a cold desert. So really cold winters, hot, dry summers. That's the best example. And if you look, here's the first example that we've really seen of very hot temperatures. So you can see that it gets really hot. And you're looking here on this y-axis, that's the temperature. So you can see that it gets pretty hot in the hot months. A great example would be Oklahoma, so kind of Midwest. And then we move to tropical rainforests. And so all of these tropical rainforests, if you look at all their distribution, they're going to be really close to the equator. So think high precipitation, high temperatures. We've got high productivity, which is why we have some of the most biodiverse places on planet Earth near, in these rainforests, which is amazing. Hopefully you did this math, and if not, make sure you do it because it is one of the requirements for the summer. Then we move to the savanna, which is great. I'd love to go to the savanna, but you want to think about the savanna as they have very little rainfall, but when they do get a rain, it's a lot of rain. So think like monsoon seasons. I always like to think about like Jumanji, if you've ever seen that movie. But just think warm temperatures, and they have most of their precipitation during the summer. And so you can see where this biome is latitude wise all throughout the world. And then we move to finally the hot desert. And so it is what it says it is, right? So really hot. If you look, consistently hot temperatures all year round, very little rainfall. Rainfall. And if you look, very sparse vegetation. And the organisms that are able to thrive there, they have such great adaptations that allow them to, obviously not succumb to the heat. And then the last thing to end with here is that the worldwide distribution of biomes, it's dynamic, meaning that it's ever changing. So distribution has changed in the past, and it's going to probably shift again as a result of global climate change. So as places become warmer, maybe it's not raining as much, these shifts can happen. So, places that were once lush rainforests could potentially become deserts if the right set of, factors kind of play a role. And so I hope that you found that this to be interesting. And please make sure you review your x-axis, y-axis. Make sure you can read these graphs because it will really help you when you read various graphs throughout the year. All right, Module 3 will be coming in the next few days. I hope that you enjoyed Module 2, and all right, have a great rest of the day. Take care.